The empirical formula is an important concept that builds on the mole concept and allows scientists to determine the simplest ratio of elements in a compound using what is called percent composition or mass percent data. So first, it's important to note that the empirical formula is the simplest ratio of elements in a compound. Now we will be looking sometimes at ionic compounds and sometimes at covalent compounds. Now, ionic compounds, the empirical formula is going to represent the actual ratio in a compound. However, for covalent compounds, as we'll see later, covalent compounds usually require an extra bit of information because the same two nonmetals can combine in a whole bunch of different ratios in a covalent compound. While as an ionic compound, only one specific ratio is allowed between the positive and negative ions. Alright, in order to determine empirical formula, we have to have something called percent composition data. This has to be provided to you. Now we have techniques we use in chemistry labs to actually find the percent composition, but it basically tells you for a given sample of a compound, let's just know what elements are present, and the percent of mass of the compound from each element. Okay, so this is the data that we begin with in order to determine an empirical formula. And I'm going to walk you through the steps that you will need to do an empirical formula. To follow along, you're going to need two things. You're going to need your periodic table, and you're going to need a calculator. Alright, so let's look at the steps for an empirical formula. And then I'm going to do an example problem to walk along with the steps. Okay, the first step is we're going to assume 100 grams of the unknown compound. The reason that we do this is in our sample problem we're going to have percent information. We need to get to grams. We need to know how many grams of each element that we have. And one easy way to do that is because since percentages are constant no matter how much or how little of a compound we have, it's simply convenient to assume that we have 100 grams of the compound. Alright, now I'm going to do kind of a complicated example, but that way you'll get something nice and juicy, and so you'll be able to do simpler ones. Alright, so we're going to start with 35.5% carbon, 4.77% hydrogen, 8.29% nitrogen, 13.6% sodium, and 37.9% O. Okay, so these are our numbers. Okay, so assuming 100 grams, all of the percent symbols become grams, because 4.77% of 100 is 4.77. I told you, this is a convenient assumption. Okay, so now we have some grams to start with. Alright, the next thing we're going to do is we're going to divide each of the grams by the molar mass of the element. Okay, so we got carbon, hydrogen, nitrogen, sodium, and oxygen. So we're going to need to divide each of these amounts by the molar mass of the element. So 35.5, we're going to divide by 12.011, because that's the molar mass of carbon. Okay, let's poke that in our calculators. Okay, that's 2.956. And what we've done now is we're converting to moles. Okay, now I'm going to do 4.77. This is hydrogen, so I'm divided by 1.0079 because that's the molar mass of hydrogen. Okay, and that's 4.733 moles of H. Okay, I'm going to take 8.29, that's nitrogen. Divide that by 14.007, that's the molar mass of nitrogen. Okay, now we've got 13.6 for sodium divided by 22.99. Okay, that's 0.592. Okay, and then lastly we've got 37.9 grams of oxygen divided by the molar mass of O, which is 15.999. Okay, and that's 2.37. Okay. Next step. This is the step that students always forget. Do not skip step 3. Now, the purpose of this, step number 3. At this point in time, we now know how many moles of all of these different elements are part of the compound. Basically, a formula can be thought of as a mole ratio. The problem is that these have lovely decimals, and chemical formulas don't have decimals. So we need to convert these into whole number ratios so that we can have whole numbers in our chemical formula. Now, which is the smallest number? Well, these two answers right here are equal, and they're both the smallest answer. So I'm going to divide every single answer here by this number. So I'm going to divide 2.956 by 0.592. And I'm going to see if I can round this to a whole number. Okay, my calculator says 4.99. That's pretty much 5 carbons. Okay, and I'm going to take the 4.733. This is H now, and we're going to divide it by 0.592. And hopefully I'll be able to divide that by a whole number, to round that to a whole number. Okay, that's 7.99, which is basically 8 hydrogens. Okay, 0.592 divided by itself. That's 1 nitrogen. Okay, 0.592 divided by itself. That's 1 sodium. Okay, make sure you track. I'm taking each of these answers and dividing it by the littlest answer. Okay, and then lastly I've got 2.37 over 0.592. Okay, and that's 4.00, so that's 4 O's. Alrighty, getting closer. Now, this is the optional step, okay, which means you may or may not have to do it. Okay, if any of your answers here come out to like 1.5 or 2.5, okay, don't round. This is a little bit like, remember we were balancing equations, we said you needed like 1.5 or 2.5, and that wasn't allowed, and we fixed that by multiplying all of the answers by 2 instead. Okay, that would convert 1.5 to 3 and 2.5 to 5, so that way you get, okay. However, none of our answers here came out to something 0.5. Okay. Now we're ready to write the formula. Okay, the answers from number 3 here are the subscripts in the chemical formula. Now if I had to do step 4, then the answers to step 4 would become the subscripts. Okay, so now I've got 5 C's, so I'm going to write that C5. I've got 8 hydrogens, so I'm going to write that as H8. I've got 1 N, so just write N. Remember, I don't have to write 1s in formulas. I've got an Na, and I've got 4 O's. There's my answer. Now normally the metal would go at the beginning. That's just kind of a quirk. We always have the metal at the beginning. So it's Na, C5, H8, N, O4. That's the empirical formula of this unknown compound. Yep, that's it for empirical formulas. Just make sure you follow all the steps. These should round to whole numbers, but don't round if they're 1.5 or 2.5. Good luck.